This is my new Sattley engine. New to me anyway. It's a 1.5 horse, and they're known as the new Sattley engines because they don't have the spoked wheels. Seems to be mostly everything is there. The only thing I'm missing is a gas tank, and I got all these pieces, and this rocker arm has a lot of wear. You can see a lot of wear in that hole. I had to weld that up and drill it out. And other than that, the main cause of failure was this wrist pin. And I think I have most of the parts. The top is broken off of the plug, but I think I can just solder a piece on there. It looks like at one time the whole back end broke off of this thing, and they've welded it here, and then they put this brace across here, and there's one on the other side too, and they welded the bottom of it. I don't know how they could break that. Must have dropped it or something. There's a lot of corrosion on the flat surface that they had here. I'm gonna take these out. I've got this tool here. I think this is might have belonged to my grandfather, and I've used it maybe 2 or 3 times over the last 50, 60 years. But this is a great little tool for taking studs out and putting them in. I already broke these loose with a big breaker bar. Gotta lock it on there. Sometimes it takes a little doing. Got to keep the tension on it, otherwise it spins off. Yep, not getting on. There we go. So this surface cleaned up pretty good. I thought I was going to have to do some repair or JB weld on it, but it's actually pretty smooth. Here's the pieces of the governor. This has to come off before you take this off the shaft. And this piece here has to be driven in, so you don't want to hit this thing, so you put a thing like that and smack it with a hammer and it'll knock it in. Okay, I got that out. I'll clean that hole up a little bit because it'll be harder to drive it back in. It was a little tight. From this side you don't have any way to push it. And I assembled the pieces back together as they were. And these 2 nuts serve as a lock nut. Once you get your adjustment, then you tighten those 2 together, and that's your lock nut. Okay, before I hone out the cylinder walls, I want to get as much loose rust off as I can. So I bought this abrasive ball. This one happens to be 400 grit, and this was a 4-inch ball, so the 3 3/4 bore. So I couldn't force it in there, so I ran it backwards against my wire wheel on my grinder. I just cut it, spun it like that, and cut off, like an 1/8 inch on each side. I already did this, but I'm going to give it a little extra. Tap and clean up these head bolt holes. These go all the way through to the water jacket, so you have to put a good sealer on the threads when you put the studs in. Okay, these lower bolt holes, there's no room to spin that, so get yourself an 8-point socket. Get a set, because various sizes will fit in various size taps. Then you can get out past the area that you're working at. Okay, I've got some honing oil here. This hone comes packaged, and to keep it, you know, they've got a band wrapped around it, and so when you cut that band, you got to stand back, and you'll end up with something like that. Don't go too far. Don't want to come through out the other end and have the stones get outside. Okay, I've got it sort of done. It's done as good as it's going to get. You can see where after the pin broke, it scored the wall right there. But I'm going to live with it since it's just not a working engine, just a show engine. These edges on here are really sharp. Right there. That led to my second bandage. Cheap Chinese stuff, I guess. I got the painting done on the main block and the head. I used valve grinding compound on the valves and the seats, and it came out pretty good. Valves used to come with like grooves, where you could put a tool in here and work the valve back and forth with grinding paste. Another old-fashioned method they used to use was a suction cup like that. You put the grinding paste on there. Of course, this is 50 years old, so it didn't stick very good, but you just work it like that. But I came up with a better method. And just go like that. Keep working back and forth. The valves are the same size, but the exhaust valve will have a lot more wear on it, a lot more heat, so you can get a little pitting on it and stuff like that. And also the exhaust valve stem will have wear on the top of it from the push rod working on it, whereas the intake valve has no push rod, it's just a spring, so it'll be nice and flat on top. I couldn't figure out why this flywheel I couldn't drive it off of the shaft, so finally I started feeling around, and I found down here that the keyway is broken off in there, so I need to drill it out first with a smaller drill, and then with a bigger drill. And this is a 5/16 keyway and a 5/16 drill. So before I started, I started with the 5/16 just to center it and drill just enough to get the center of the shaft, you know, the center of the hole, and then I can go ahead and drill it with this. And you got to drill all the way through. And I'll probably drill like a 1/2 inch down, and then to keep from breaking it off, then I'll use this to get down to that 1/2 inch, and then keep a bit at a time. Okay, let's see if this thing moves at all. I poured some hot water over it from my water heater. Good time to drain the water heater, partly. Supposed to do that a couple times a year. And that loosened it up a bit. Now I'm giving it a little more heat. that. Maybe this will make it a little quieter. We'll see. Maybe not. It's going down. Do the brass drift here. Okay, once you get down past the lip, you don't have to worry about it belling out. And use something like that and a bigger hammer. Got it out. I'm going to make a muffler for my 1.5 horsepower Sattley engine. I'm using the back end of a propane cylinder. I used a metal cutoff blade on my chop saw to cut it. Of course, made sure it was empty. And I actually drilled a hole in it to make sure I could blow some air in there and make sure there was nothing in there. Then cut the bottom end off, drill these holes in it. Wish it was a little bit heavier metal, but it'll probably work for the little use I use for this engine. It's a 1.25 inch thread on the exhaust pipe on the head. This is a pipe stand. I'm going to cut it to fit. Okay, I've got it cut down on my ledge. This must be cast iron because it sure puts out little tiny chips. I got a little ledge there to fit it on, and I'll weld it up. I'm going to make some kind of a baffle in here to kind of break up the flow. I've got the baffle welded in there. Okay, this is for rebuilding my oiler for my little engine. I got it online pretty cheaply because the sight tube was broken. That's glass. I was able to find some polycarbonate tubing of the same size at Granger. I was able to cut it, put it on my lathe, and use a razor knife to slice it as it's spinning, and then cut it off pretty close, and then sand it down to the right size. Clean these up and see how it works. I got the oiler cleaned up, replaced the sight gauge with the sight glass with lucite. That looks pretty good. Found another problem to solve where the oiler screws in there. Over the years, I guess it's leaked and they tapped it and keep getting the hole deeper and deeper. So now it's hitting this little metal thing right on top of there, and before it gets tight enough to seal, so I got to grind that down a little bit. Okay, I ground it off, and there it is, and should work. I didn't have much luck turning the crank on the lathe. I got really messed it up, so I had to take it down and have it ground. And it took off like 25 thousandths before they could get it cleaned up. But looks real nice now. Now, I've discovered a new problem. The rod is bent. And I should have figured that out, that there might be a problem because the wrist pin was broken. But you can see how it diverges there. So I'm going to heat it up right here where it's bent, and then put some force on it here with a pipe wrench and bend it over. So I want to make sure, I don't have any precision equipment to make sure that the main journal and the rod are parallel, so I'll do the best I can. First I want to make sure that this is in the vise level, so I have my laser level there, and to make sure that that's level there, and then I'll turn it around and shine it the other way, and you can see the laser line on the rod. You can see how it's bent, so I'll straighten it out. Okay, sighting along the bottom, I tried to adjust that so it's perfectly level. Put a little shim in right there to make it level. Okay, heat it at once and try this. Vent it, and that's pretty close, but I think I'll give it a little bit more. Okay, you can see that it's pretty level here. Of course, these things are not perfectly straight here, so you don't get but it's as straight as I'm going to get it. Okay, here's the shim packs I've made for the main bearing cap, so I'm going to clamp them in there and then saw off the excess. There, and then I'll finish it off on the grinder. And there it is, finished off. I'll be using that in different areas when I pour the babbitt bearing. The first thing I formed was this little thing here that makes a little channel to pour the babbitt into, and this blocks it from flowing out, and it'll flow under the main bearing crankshaft. Then it'll flow under the main on the crank. And when it gets up to this level here, I'll stop pouring. The new piston pin was a little bit tight in here, so I got a rod, or in this case I found a socket that's just a little smaller. Wrap around some emery cloth around it, and I can clean it up like that and make it slip in better. Once I cleaned it up, I took a chisel, used it there, just drove it in a little bit to spread it a little bit, and that made it a lot looser. Okay, to hold the rod in place while I pour the new babbitt bearings, I used this piece of flat aluminum, and I made sure it was flat. And then I used the old broken piston pin that's gonna hold this in place. And then I machined this like 2/1000ths bigger, maybe 3/1000ths bigger than the actual journal on the crank for clearance. So when I pour the babbitt, it'll have some clearance. And I'll put this on here, get this centered exactly in the center, and then tighten it down. And I'm going to pour the bearing with the shim pack in place, of course. And then I've got these little notches here that fit this ring. And that ring fits right there. And that's going to pour the thrust bearings on each side of the rod. And of course these shims have to extend past there so that I can be able to, after I cast it, split it apart. And these things center and also keep the babbitt so I can split it apart. After I pour it and after I'm done, I'll shave these down so they're not touching the journal. Okay, I've covered the rings and the arbor with soot from the settling torch so that the babbitt does not stick to them. Okay, everything's in place. It looks like it's centered pretty good. I have the cap marked with a punch mark, so I've always put it back on the same side. Okay, I added some of that fire stop stuff there both times just to keep the ring in place when I pour the lead. You know, make sure it's perfectly dry. It's water-based, and if it's not dry, you'll get a little tiny steam explosion when you pour the hot stuff in there. Then I measured the difference between this end and this end, cut it in half, added 3/30 seconds for the little rings, and then make sure that this thing is the same level. A lot of leakage there. We'll take it apart here. I cooled it down with water. Take it apart here and see how it happens. dig this off so I can get the nuts off of there. Slag chipped off pretty easily. Yeah, looks pretty good there. I'll have to put this in the vise to get those nuts off of there, but this one's tight. Okay, I can see the dividing line on this one here. This one's got a little bit, I'm going to have to work on that a little bit. Let me get this ring off of here. I'll have to work on that a little bit. Get it scratched off so I can split this. Get this sharp point from my lathe tool. Works pretty good for cleaning this stuff up. I use my wire wheel on my grinder to clean up a lot of the overlap, stuff that's sticking out here. Just a light tap is all it took was to get it to come loose. So, the moment of truth. Yeah, looks decent. Yeah, that'll work. Now I need to grind these down so they're not sticking out past the babbitt, and I can also take off these little tabs here, grind them off too. Okay, I clamped a rod in here, and then I drilled this thing out like this is the old mandrel I made to hold everything in a line. And I filled the center with babbitt, drilled it out a 1/4 inch rod, and then I measured between these two rods on both sides to make sure they're parallel. And now I'm going to make an instrument or tool to try and check the alignment of this thrust bearing to make sure it's square. Okay, so I've got this drilled out now. I can put it on here. And I can slide it down. And I can see there's a lot of clearance on this side, so I've got to shave this side down, make it square. The same thing on this side. Well, not quite as bad, but there's a gap here when this is touching, so I got to shave this side down. So this is the tool I made. It looks kind of Mickey Mouse, but it's going to work. Okay, I got close with the tool. Now I'm grinding or sanding. Now I'm filing. This is originally a body lead tool, but it worked good on this rough cut. And then I'm going to finish up with a finer file. Check it every now and then. I'm going to get down to 1.5 inches. So I'm about 17, 18 thousandths still to go. Okay, I've got that narrow enough. I got it narrow enough to fit. Now I got to use a bearing scraper to make sure there's clearance for the radius on the throw. fit the cap on there and make it sure it spins easy. This square tubing is a good way to hold a clamp it in the vise without messing up the round part. This bearing was pretty tight on there, so I'm going to scrape off a little bit. I put some bluing on there so I can see where I've scraped and where I haven't. I put some Prussian blue on the shaft, a very small amount, and you look for places where the blue has dragged a little bit, and it'll mark the high spots. Now if you happen to have some little valleys and low spots, there'll be blue in there too, but if you run the fairing scraper very lightly across there and it doesn't move at all, it means it's a low spot, not a high spot. There's the finished bearing after I scraped the inside and made them fit, and also filed the flat surfaces here to make them parallel to the pin, to the throw. Okay, I'm positioning the crank. Have to make sure there's clearance for the timing gears. And I'll use this block of wood, and I can adjust the height up and down with this sliding this thing here. And I have determined it to be halfway up. It has to be 613 or 614 thousandths up above this. So I'm using 5/8 nuts, which is 625, and then a sliding bar across here for height, and then I'll slide a feeler gauge under there and adjust this till I get the right height, and then I'll do the same thing on the other side. Okay, I've got some spacers under these rings that are going to form the thrust bearings. The spacers hold them up in the right position, and then I put a little hot glue to hold it in position while I'm going to have to rub sealer underneath here and underneath here and here and here, in order to make sure the babbitt doesn't leak out down there. And in theory, when I pour the babbitt in here, it should flow through and come up to the level there and then stop. And that's hopefully. The first one came out good, looks like. I'm getting ready to pour the second one, and I scoop the slag off the top, the dirty stuff, off the top of the molten. Okay, I'm ready to try the second one. Some people say you need to heat everything up 250 degrees, but it's hard to do, so I had good luck not heating things. This one did not pour as well. I'll have to heat a little bit more and put a little bit more on this side. Okay, I found it's a lot quicker to use a propane torch in addition to the fire and get it going fast, melt a lot quicker. These rings have to come off before it can lift out, so I can get them out of the way. Same here. It looks pretty good. The thrust bearings look good. Thrust bearing surfaces. Of course, then you have to file this perfectly flat here to match, but other than that, it looks pretty good. I thought I was going to have to do a lot of filing, but actually this old chisel works pretty good for peeling this stuff off of here. If I can get it in the picture, there it is in the picture. Yeah, this old chisel works pretty good getting that off of there. Then I'll file it to finish it. It was taking quite a while to file these. Got them down pretty good, but this was pretty high here, so I took my Sawzall and I hand sawed just to get a good start, because it doesn't matter if you cut a little bit of an angle here, because your spacers and shims are resting only on the metal. So that cut there off pretty darn smooth, and just have to do a little filing. I really like that. It saved a lot of time. I don't know how critical it is, but you can see that I've got lots of spots that are low, that's not touching. And if I put this cap on here, I can wiggle it a little bit, even if it's clamped down. So maybe it doesn't matter if you always clamp it in the same spot, you clamp it down and pour your bearing. But I think what I'm going to do is put JB Weld cast iron on these spots here, and then put some oil on top of these so they don't stick, and then clamp them down, and that'll form that should make a form there to fit flatter. Easy enough to do. The JB Weld came out pretty good, pretty flat. The caps sit on here now, and they don't rock. They're steady. Okay, I had to cut these rings that are going to form the upper part of this thrust bearing here, so to be able to split them enough to get them on there. And once I've slapped them on there, then I'll wrap some wire around them to hold them in place. Okay, I put some more soot from the acetylene to make sure nothing sticks when I pour the new lead. Okay, these two top shims I made extra wide so they fit right up against the shaft to keep the babbitt from running down too low. So I put some soot on these too, and then button it up. I found it a little too difficult to wrap wire around there to hold these in place. So what I'm going to do is use just a little bit of hot glue gun just to hold it temporary, and then I'll put the heat resistant sealer on it and let it dry, and that'll hold it all in place. And it won't matter if the hot glue melts after that. And here, so the ring is kind of crooked, so I'm just going to fill this in with the heat sealer and be fine. Almost forgot to clamp these down tight. Got to have them in place with your spacers. I'm leaving out 2,500 spacers on each side, because this stuff seems to pour pretty tight, so then when I take it apart and put the new spacers in, I'll have some more clearance. Okay. That's about 250 there. One side. Okay, you can see that the babbitt got past this little dam that I built. I should have built just a special one that stuck out farther so I could push it in and make sure it was against the shaft. Also, I had more leakage around the edges here. I should have put some more sealer along the very corners. So much leaked out that I ran out of babbitt, so I had to do a second pour. You can see the line from the second pour there. Actually, the first pour would have been the bottom part, second pour, but because I had it hot, it worked pretty good. The second pour stuck well. Now I got to just figure out how to get all this off. Okay, that cleaned up pretty good. You can see the second pour there, and there. It came out all right. You have to drill this out, and then eventually I'll tap it and put in the resert fitting. Okay, I didn't get a complete thrust bearing pour on the top half, but it doesn't really matter because the bottom half provides plenty of thrust surface. After more than an hour's struggle, I finally got that bolt in there for the wrist pin. It's a Model T wrist pin. I don't know if there's a slight difference between the Sattley setup and the Model T setup, but I had to grind the notch in the grist pin bigger in order to finally get that bolt to go through there. And then I had to grind a little bit on the rod in order to be able to get a socket wrench on this nut, even though it has a tall head on it. So now all I got to do is wire it up with through that hole there to make sure it never comes undone. When I install the piston in the engine, I want to make sure this hole is on top, because that's where the oil comes down this groove and drops right into that hole and oils the wrist pin. Okay, I used some Loctite and put about 35 foot-pounds pressure on it, and then this cotter key will keep it from coming undone. You also can wire it, take the wire all the way around the rod. This should work. Got a ring compressor on here. Makes it a lot easier to get these pistons, these things in there. Okay, I'm using Time Saver burnishing compound to seat in the bearings. This hole here for the rocker arm is going to be, or actually it holds the rocker arm, 3/8 clevis pin. It's oblong, so I have to weld that up and re-drill it. One of the many problems that come from buying a basket case is you didn't take it apart, so you're not sure how things go together. Even if you have the manual, it's not easy, but I'm getting there. I couldn't figure out had a funny pattern to the cam, and I figured out that the cam has two actions. It pushes this rod part way on compression to work the magneto which sits here, and then it goes farther after the power stroke. It goes farther and opens the exhaust, and so the exhaust is supposed to open when this is 5 degrees here past dead center. So I made a cutout that's 5 degrees and stuck that in there underneath it and measured it. Okay, and then the other one was it starts to close, or is totally closed at 45 degrees. So I made this here and then line that up with the bottom of that, the bottom down here, and make sure it's. Another thing I discovered is that the keyway that locks the flywheel on doesn't reach far enough in to lock the timing gear in place, so I had to make a little short piece that locks that in place. Okay, I got it set up 35 degrees before top dead center, and what I found out was it makes a difference which way this gear is turned. You can put it this way, you can turn it around and put it that way, and that makes about a half a tooth difference. So that's why I was having trouble getting it lined up. This is a gas tank that was made for a Sattley engine, but it must have been an earlier model because it fits differently. This one's set up with straps that stuck out here. We're supposed to go on there, but that makes it too high. The original unit had a groove in it right there where these would slide in, so I cut them down shorter, and I also lowered a little bit better to make it a little easier to work on the fitting down here. But I put this in and decide where it's going to actually sit. Okay, it's going to sit about there. That's what it looked like from the picture. This has to be over here where you can reach it, and this has to be right directly underneath this, which is the intake for the carburetor. So I got to unsolder these and drill a hole and move them over and then plug the hole. Okay, I've got this one moved over and this one moved over, and I hooked this up and had this loose and then got it right directly in place, and then soldered it on. This galvanized is difficult to solder on. You need a good solder and you need a special flux. So I've got a few leaks. I'm just going to use JB Weld to patch this last one, and I'll use JB Weld around all the way around these just to make sure they don't leak. Okay, I'm setting up the timing of the gears. Just can't read this anymore, but I know from the book that says exhaust opens. So when it's lined up with this line, then you wiggle your adjustment here until it's, adjust it till it's just tight. If you're off a little bit, see, I can go like that. So if I roll it up to the line, and it's tight. Okay, so then I go all the way around to exhaust closes. And right there, it's loose, so okay, see, it's not going to be exact, but it's close enough. Okay, and then I punch mark if you're off, you slide this gear out and move this till you get the right position. Okay, this is the gas pickup. The brass ball in there was pretty corroded and the seat was pretty bad. So I took it apart and cleaned it up, and then it still was not seating well, so I took a steel ball. This uses a 3/32 ball. So I took a steel ball and stuck it in there, took the bad brass ball out and took a drift and pounded on it several times to make it shape the brass into a better seat. And then I ordered a brass ball, 5/32, and put it in there. This has slots on the bottom right there, so that even if it touches the bottom of the gas tank, it still sucks gas in. You want it as close as you can get, so you don't run out of gas at the last minute. Okay, and then you slide your gas tank in. And you can't have this too tall, or it won't fit. It won't slide under the carburetor fitting here, so it has to slide underneath that, right about like that, and then you bring it up and tighten it up. Okay, when mounting the Wyco mag to the Sattley, you've got to be, it's really tough. You get this top nut on here, it's really tough, so don't tighten this one too much. Put this one on first, but don't tighten it too much, so you can rock this out a little bit, and then you got to get in there with your fingers on each side and get that nut started. And don't use lock washers, because there's not room there's just not room to get the nut in there very well. I just used Loctite. And then don't put this mechanism in here, the bolt, because you need the space. The only place you can get to that and turn that nut up there is right through there. Okay, so getting this on here was really tough too. So what I did is I slid this all the way down and locked it, and then I was able to pull this spring back and then get this out of the way, and then this could drop down in here. Okay, you don't want to lose the little nut that goes on behind here. It's a 1232, which is kind of a strange one. And I'm going to put that on there with Loctite. These adjustments are all pretty critical. Just a little change makes it not spark. But this is the drive spring, and when the push rod pushes against here, it puts tension on it, and then inside of that there's a sleeve inside there called the trip shoulder, and when that finally touches this, it forces these brake, the armature is forced down from the magnets, and then the spring's tension makes it kick fast. The faster it breaks, the better for the points. And so that's and this is a return spring, and if you have that too tight, then it doesn't open fast enough. So you gotta play around to get the right adjustment on that spring there. And I'll turn it and show you how fast it's supposed to break. And these nuts here, these adjust the timing, so in relation to the cam, so you adjust that to it fires at the right time, and then you tighten the lock nut up. Here's a problem I discovered with the reproduction mixing valve for this Sattley. They're not manufactured exactly the same way, and this is taller, and therefore when you try to screw it on, it hits this flange here. So what I ended up doing was grinding the flange away in that area to make it clear. Whatever you do, and I found out the hard way, is don't remove this to make it easier to screw on, because this is inside here is a 1/8 pipe thread, and it's threaded in, and after it's threaded in, they drill it and tap it with 1/4 32 tap all the way through it, and you'll never get it to line up again. And then when it doesn't line up, this doesn't go all the way in and seat the needle valve. So believe me, don't take that out. Also, the nuts that are on here are 9/16, and there's no room to get a 9/16 socket on there, and when the thing is assembled and the gas tank's in place, it's really difficult to get to. So what I did was I took the stud out of the head, and now I use a 5/16 course bolt, and it has a 1/2 inch drive head, and then I can get a socket on that.